Our lesson this morning is all about Module 4 entitled The Effects of Heat to the Speed of Sound. So this is week 4. So what is the MELC or the most essential learning competencies for this? So you are expected to learn or investigate the effects of temperature to the speed of sound. At the end of the lesson, dapat ma-achieve natin ito na goal natin. So from the most essential learning competencies, ito naman yung mga unpack MELCs or objectives. One, actually it's all about sound. So we have to define sound. Second, we have to identify what are the characteristics of sound. And then third, we should be able to describe the effects of temperature to the speed of sound. This is not question mark. And then number 4, to explain some factors that affect. So aside from the temperature, what are some other factors that affect the speed of sound? And lastly, you are asked also to compute for the speed of sound. So be ready with your calculator, students. Okay, but before that, let's have a review. A review for our previous lesson. So this is what we call as 4 pics, 1 word. So I'm gonna show you 4 pictures and then you have to identify what is the keyword or the word. So let's start. In your notebook, you write number 1 and then you write your answer. So these are the 4 pictures. The leaping frog, accelerating car, the flowing water, and the jogging athlete. So what do you think is the key word or the word for this? Very good. So the answer is kinetic energy because we said before that kinetic energy is the energy of motion. So leaping frog, it's in motion. So therefore, a leaping frog is an example of a kinetic energy. Accelerating car, it's still in motion. Flowing water, it's in motion. Jogging athlete, for example, is still in motion. So these pictures shows kinetic energy. How about number 2? The pictures are, first we have the rubber band. Second, we have the chemical energy. Then third, we have the nuclear energy. And then the fourth, we have the gravitational energy. So what is the answer? The answer is potential energy. These are the examples of potential energy. Can you remember? Chemical energy, the energy stored in a food, in a fuel, and anything. Elastic energy is an example of potential energy. This one, matching type. So we have column A and column B. So for number 3, if the mass is doubled, what do you think is the next phrase or statement? If the mass is doubled, what do you think is the next answer for that? The kinetic energy is doubled. So letter E is the answer for number 3. How about number 4? If the velocity is doubled, what's the next sentence or statement for this? Letter D, the kinetic energy is quadrupled. Number 5, the potential energy is directly proportional to blank. What should be the answer for the blank? Letter C, because statement talks about potential energy. Okay, so potential energy is directly proportional to height. The greater the height, the greater the potential energy. Okay, number 6. The factors that affect the kinetic energy are blank. Very good. Letter B. So the two factors that affects the kinetic energy are mass and velocity. Can you remember this one? I-discuss natin ito. And then last number. Okay, the factor that affects the potential energy is, the answer is letter C, height. Okay, so na-answer na natin yung previous na learning competencies na identify the factors that affects the potential energy and kinetic energy. So, na-achieve na natin yon yung previous natin na learning competencies. So, let's start now our lesson. Actually, this module is all about sound. But since the most essential learning competency or MELC is to investigate the effects of temperature and the speed of sound, we will first discuss about sound before we proceed to the effects of temperature to the speed of sound. Okay, so what is sound? So sound are vibrations. They are the results of vibrations of air particles that travels through the air. So sound is transmitted in air through vibrations of air particles. So take a look at this example. This is a guitar. When you pluck a guitar string, the particles surrounding the guitar begins to vibrate from side to side. So let us see, these are the particles surrounding the guitar. So what happened now to the particles when you pluck the string? Okay, they will start to vibrate. So hindi lang natin nakikita. Actually, ito ang result if you start plucking the guitar. So let's pretend that these are the particles. So nakadistribute siya around the guitar kahit saan. So when the string moves to the right, so pag imuha niya siyang i-pluck, lahat ng mga air particles will be pressed together. So merong part ng mga particles na nag-group, merong part na wala, meron ding part na naman na nag-group. Okay, actually this part, one, yung nag-group ng mga air particles, this is called as compression. So what happened to the particles is para silang na-compress in one and then walang air particles and compressed na naman. So actually, this is how vibrations of air particles looks like. Okay, let's proceed. In other words, sound is a wave. It's a wave that travels outside or outward from the guitar. So the source of sound actually is the guitar. However, the air particles themselves do not travel. So hindi sila actually nag-travel. They are just oscillating, meaning nag-move lang sila back and forth in a form of vibrations. Okay, so that is why sound is a vibration. Okay, sound consists of waves that travels or propagates through a medium. So take note that sound cannot travel without a medium or media. So for example, in a vacuum, sound cannot travel. Why? This is because it needs a medium or a media. A medium could be in a form of gas, solid, or liquid. So any medium na pwede niyang i-travel, yun ang pinaka-requirements ng sound. So kung walang medium, walang mga walang medium, like for example in a vacuum, so sound cannot travel on it. So it really needs a medium for a sound to vibrate or travel or propagate. So since it needs a medium, it is called as mechanical wave. So actually sound is a mechanical wave. So let's review first in your grade 7. I think na-discuss na ito. So let's describe first waves. So there are kinds of waves. So waves are classified into two. One of these is longitudinal wave or waves, and the other is transverse waves. So what's the difference between the two? Let's start with the longitudinal wave. So these waves are created by pushing and pulling the medium. So if you want to imagine how does longitudinal wave looks like, ito yung ano niya. So have you seen a slinky? Sino na nakakita ng slinky?
Ako
Yung
po.
parang, very good, spiral. Actually, slinky is the best model for creating a waves. So, okay, so parang ganito siya. Sabihin natin, gamitin natin for example ang slinky para makita natin ano ba ang kaibahan ng longitudinal and transverse wave. So actually ganito mag-act ang wave kasi hindi natin makikita ang sound wave. So gawin na lang natin is mag-ano tayo ng model. So let us see a slinky. So kung i-push ni ma'am ito ng yung slinky and then back, what happened is there are parts na nag-compress, there are parts of the slinky na nag-spread, then compressed, and then spread, and then compressed. So this is what happened to the longitudinal wave class. If there is a force applied, like for example, pag i-pluck natin ang string of the guitar, so what happened is merong force na sa mga air particles. So what happened to the air particles? They are oscillating, moving back and forth, forming one part na nag-compress. Ang tawag dito sa mga part na nag-compress ang mga particles is what we call as compression. The part na nag-spread out, this is the rarefaction. And the distance from compression to another compression is what we call as wavelength. Okay, so what is the movement of this wave? The movement of this wave is back and forth. And it is parallel to the applied force. So the applied force is pushing and pulling. So they are parallel. The movement also is same, parallel to the applied force. And the longitudinal wave is created by a force applied. So sinabi na niyo ito kanina. So therefore, longitudinal wave is also called as a pressure wave. So sound wave is an example, hindi natapos ni ma'am, of longitudinal. It's an example of longitudinal wave. Ang heat naman is an example of transverse wave. So ito yung mukha ng longitudinal wave. Okay, how about transverse wave? These waves move perpendicular to the movement of the particles or force. So an example of transverse wave is heat, the wave of the heat. Okay, let's proceed. So kanina sa longitudinal wave, parts of longitudinal wave are compressions and refraction. But for the transverse wave, ito ang mga parts niya. So, paano ba ma-form ang transverse wave? By moving this slinky, for example, up and down. Okay, so ganito ang form na ng transverse wave. Meron siyang, ano ang tawag dito sa upper portion? This is the crest. The lower portion of the transverse wave are the trough. And the distance from the crest down to the marginal line is what we call as amplitude. So what is now the movement of the wave, transverse wave? It's up and down, and it is perpendicular to the direction of the wave. Okay, so balikan natin. So in this wave, trough and crest are produced. So meron siyang lower portion, that is the trough, and the higher portion of the wave is the crest. So this one is the highest portion of the wave, transverse wave, I mean. These are the crests. And the lower portion of the transverse wave are what we call as troughs. So the movement of the transverse wave is up and down. And it is perpendicular to the direction of the wave. So ang direction of wave is ganyan. But the direction of the movement is perpendicular. Let's proceed to the characteristics of wave, particularly sound wave. So one of the characteristics of sound wave or wave is wavelength. What is this wavelength? Wavelength is the distance from one compression to another compression. That is for longitudinal. So ang wavelength dito, class, is from compression to compression. Pwede din from trough to trough. That is why ang meaning ng wavelength is the distance from one compression / trough to the next compressions or trough. Okay? And the unit of wavelength is in meter. Okay, so transverse wave, ito yung wavelength from crest to crest or from trough to trough. That's the wavelength. Okay, let's proceed. How about the second characteristic of wave is frequency. What is frequency? This is the number of compressions passing by a certain point in 1 second. So kung balikan natin, not only compression, pwede din siya refraction, the number of refractions. Pwede din the number of trough. Pwede din the number of crest. Okay, so in the case of longitudinal wave, to measure the frequency, you have to count how many compression passing through in a certain time, 1 second. Like for example, dito, 1, 2, 3, 4. So 4 compressions, that's the frequency. Pwede din ang trough, count mo lang, 1, 2, 3. Okay? So this is what we call as frequency, the number of compressions / or kung ang basihan mo trough, pwede din trough. Kung ang basihan mo crest, pwede din crest. Pero dapat kung crest lahat ang i-count mo. Okay? Dito naman sa transverse wave, so ganun po rin, the number of crest passing through a certain time. Okay, so ganyan. Or pwede din trough. So that is what we call as frequency. And the unit of frequency is in Hertz or Hertz. And the higher the frequency, the higher the pitch. So ano ang mapansin natin kung higher usually ang pitch niya? Daghan kaayo siya og frequencies. Have you seen ang frequencies sa symbol ng mga frequencies? Sa mga component natin, di ba usually meron yung parang mga waves galing na nag-travel. So, yun ang mga samples of frequencies. Okay, next, pitch. So we mentioned about pitch, that the higher the frequency, the higher the pitch. So what is pitch? Pitch is describe how high or low a sound is. And it is measured in terms of hertz. So just like our human ears, they can only hear up to 20 to 20,000 hertz. So ano naman ang tawag sa sound na that is lower than 20 hertz? This is infrasonic. And if it is greater than 20,000 hertz, it is ultrasonic. Another one, amplitude. So which one is the amplitude? So let us say this is the higher peak or the crest. So the distance from the higher portion of the wave to the marginal line is what we call as amplitude. So this another amplitude, so amplitude. This is actually the height from the marginal line to the highest peak. Okay, so take note that the greater the amplitude, so kung the greater ang iyang height of the amplitude, the louder the sound. So kung lakasan natin ang volume, the more the height of the amplitude will increase. So mutaas ni siya. Kung hinaya nimo, the amplitude will also decrease its height. How about loudness? The loudness is the intensity of sound. How strength is the sound? So usually the unit of loudness or intensity of sound is in decibel or dB. So sound, usually soft sound has a smaller amplitude. Okay? And then, so pag kusog siya masyado, anong ibig sabihin noon? Greater din ang iyahang intensity. Greater sad ang iyahang or larger ang iyahang amplitude. Kung soft lang ang sound, mas lesser ang iyahang amplitude and mas lesser din ang iyahang loudness or intensity. Okay, let's proceed. So we identified two characteristic na. Third is the speed of sound. Parang dito talaga ang pinaka-main topic, the speed of sound. So the speed of wave or sound is the product. So when we say product, it is multiplication. The product of what? The product of wavelength and computed or measured wavelength and the computed frequency. So let us say for example, balikan natin ang ilan ba ang wavelength niya, ilan ba ang frequency niya. Take a look at this example yung nasa natin. Dito tayo sa transverse wave. So i-count natin ilan ang frequency meron dito sa wave na to. So we have, ang basihan natin is crest. Okay, we have one wavelength. 2. So we have 2 wavelengths. How about frequency? How many crests? We have 1, 2, 3. So what is now the speed of sound? Balikan natin. It's the product of measured wavelength. The measured wavelength is how much gani yun? Ilang wavelength nakita natin doon sa sample natin? 2. Actually, the symbol of wavelength is parang baliktad na Y. Okay? And the symbol for frequency is F. Okay, so V stands for the speed of sound. So, frequency times wavelength, ilang frequency ganyan na count natin? 3 ba yun? 3. How about wavelength? Ilan yung na-count natin kanina? 2. So, 3 times 2. That is how the speed of sound is computed. Okay, period. The period is the another characteristic of wave. This is the reciprocal of its frequency. So let us say ang frequency niya is 3. The number of compressions or crest is 3. And then the reciprocal of that is 1 over F. So 1/3. That's the period. The reciprocal of frequency. Okay, next. So let's identify what are the factors. This is objective number 3. Factors that affect the speed of sound. One of these is elastic property. Elastic property is not the ability being stretched, but this is the tendency of the material to maintain its shape and not deformed. So when force is applied to the object. So let us say, for example, a steel. Steel is rigid. This is a rigid material, so its particles are very strong. So steel has a high elastic property. The rubber band naman is, or like paper, is easily deformed. So, a very low elastic property. Iba yung elastic na ma-stretch ha. This is one property of matter. Elastic property, yung hindi madali ma-deform. So, between steel and rubber band or paper, steel is more elastic than the rubber band or paper. This is because the particles are very strong, they are compact, they are rigid. So what happened to the sound in more elastic? So sound actually travels faster in a medium with sound travels faster in a medium with high elastic property or steel than lower elastic property like rubber. Ano kaya ang mapansin natin, class, pag anong tawag nito? Pag mag-shout tayo sa inside a bathroom, for example, or inside a water. So, mas mabilis kasi mag-travel ang sound sa mga high elastic property like solids than in liquid. So that is why madaling mag-refract ang mag-echo pag ang walls mo is concrete. Kasi mabilis sila mag-travel sa mga solid particles. Ito din yung ginagamit ng mga warriors noon through sa mga ng horses. Ang gagawin lang nila is lang nila ang ears nila sa ground para marinig nila kung meron ng paparating na mga enemies. Kasi mas mabilis mag-travel ang sound sa solid. And take note, the ground is solid. Kaysa maghintay sila sa sound from the air. So, sound really travels faster in solid than in gas. Okay? So, gas kasi are low elastic property compared to ground. So, mas madaling marinig ng mga warrior. Ganon din ang ano pa ba mga example nito? Diba pag nakatry na ba kayo na mag-play ng tin can na ginagamit as microphone? Sino nakatry nito? Nakatry ako nito. Gagamitin namin yung tin can, dalawang tin can, butasan lang namin, tapos lalagyan namin ng tali. And then, magtaka ka na kahit na nag-whisper ka lang doon inside the tin can, the other side, kung ilalagay niya sa ears niya, marinig mo ang sinasabi niya kahit hindi narinig ng mga persons between the two. Having a telephone using tin can. Diba? Kasi the sound travels in the tin can, which is solid, more high elastic, to the string, and then next to the next person. So sound travels faster in high elastic, which is the tin can and the string, compared to the low elastic, which is the air or the gas. Another factor that affect the speed of sound is the phase of matter, phases, states of matter. So, which one travels faster? Okay, actually the band strength between particles is strongest in solid, but weakest in gases. So sound wave travels faster in solid than in liquid, but between liquid and gas, mas faster ang liquid. So sound travel fastest in the solid. Okay, compared to the three states of matter, solid, liquid, and gas. But mas faster sa liquid than in gas. Okay. Ano ang explanation nito? Why do you think sound travels faster in solid than in liquid? It has something to do with the distance of the molecule, the particles. Kung dikit-dikit kasi, like for example sa solid, madaling mapasa ng first particle to the next particle ang sound wave pag duol ang ilahang distansya. Okay? Compared to liquid na medyo meron na siyang space between one particle and another particle. So, if the sound wave strikes on the first particle, mahirapang i-transmit ang sound sa next na particle kasi meron pa siyang gap, meron pa siyang distance. So therefore, it is faster in solid compared to liquid. The more in the gas, hindi na masyadong mabilis ang pag-transmit ng sound, pag-travel ng sound kasi mas lagyo na ang distance ng gas particles compared to liquid. So slowest, sound travels slowest in gas but fastest in solid. So yan din ang reason ng example ni Ma'am kanina na anong mas mabilis ma-transmit ang sound kung solid ang kung ground compared to air. Okay, mas madaling maipasa ang sound waves kung nasa solid siya mag-travel than in gas. Okay, third factors that affects the speed of sound. It's the density of the medium. So ano ba yung ginagamit mo na medium? Gas ba? Water ba? Actually, medium is anything kung saan siya mag-travel. That's the medium. So kung ang density ng isang medium o dadaanan ng sound is greater, slower ang iyahang movement ng sound or travels ng sound. So they are inversely proportional. The more dense the medium, the slowest its travel of sound. So for example, between tap water and oil. For example, tap water and oil. Saan ba ang mas mabilis mag-travel ang sound? We all know that oil has a greater density. So, mas hinay ang iyahang pag-travel sa oil kasi denser ang medium na oil compared to pure water. So it is faster ang iyahang pag-travel kasi less dense. Another factor that affect the sound is the temperature of the medium, kung saan siya mag-travel. So, ito yung pinaka main topic actually natin, the effect of temperature on the speed of sound. Okay, so sound is directly affected by the temperature of the medium. So, for example, hot water, cold water. You have hot water and cold water. Lalagay natin sa dalawang baso or graduated cylinder, for example. And then, you strike a tuning fork. And then, put the tuning fork above the mouth of the two different temperature, yung cold water and hot water. Sino kaya sa dalawa ang mas mabilis ng transmit ng sound? Is it hot water or cold water? So the higher the temperature, the fastest the sound will travel. So between cold water and hot water, for example, mas mabilis mag-transmit ng sound kung ang iyahang temperature is high compared to a very low temperature. Why? Why is it that it is faster to transmit sound in a high temperature? We all know that a high temperature makes the particles gains kinetic energy. So the higher the temperature, the higher its kinetic energy, meaning the higher the temperature, the movement of the particles is higher also, the more that they are vibrating. So if they are moving, they can transmit the sound easily because they are moving. Whereas kung naka-steady lang in cold water, if you can imagine the particles of cold water, they are just steady like that. And then you try to transmit sound there, dugay kaayo mo abot pag cold water. Why? Dugay man niya matransmit ang sound from one particle to next particle kasi naka-steady. Whereas in cold water, the molecules are, in hot water, the molecules are moving. So while they are moving, they can collide with each other, collide sila sa other particles. So after colliding, that's the time sila makatransmit ng mga sound wave. So the more sila na mag-collide, the more nila matransmit yung sound from one particle to another. That is why it is more greater in transferring sound in a hot water compared to a cold water because of the movement, because of the kinetic energy. So higher temperature has a higher kinetic energy of the particles, and the more na it will transmit its sound wave from one particle to another particles. So recall the four factors that affects the sound wave are the elastic property. The higher elastic property, the greater the transmission of the sound. So meaning sound travels faster in a higher elastic, usually solid. Second is the phase of matter or medium. So mas greater in solid than in liquid, but greater in liquid than in gas. Then third is the density. The density of a medium. They are inversely proportional. The lesser the density of the medium, the greater its transmission of sound, or the sound travels faster in a lesser density compared to a greater density. So the greater the density of the medium, the sound will also travel in lesser speed. Then fourth is the temperature. The higher the temperature, the greater the movement or transmission of sound. Are you ready with your calculator? So, ang basihan lang natin dito is by knowing the temperature of a certain environment or media, we can now compute the speed of sound. Okay. So, the temperature greater than 0, so meaning, for example, 1 above, is greater than 331 meter per second by an amount of 0.6 meter per second per degree Celsius of the temperature of a medium. So meaning, ang sound daw, basta more than 0, naana siya daang speed nga 331 kada 0.6 meter per second per degree Celsius. So, the equation of the speed of sound, or V, the symbol of speed of sound is V, is equal to 331 meter per second plus 0.6 meter per second, tapos the amount of, or the temperature of the medium over C, or over degree Celsius. So, the temperature, take note that dito natin i-substitute sa letter T. Temperature, ang amount ng temperature niya. Okay? And kung nawawala naman ang temperature tapos given ang speed of sound, ito na naman ang equation niya or formula. So the temperature of a media or medium is equal to the speed of sound minus 331 meter per second divided by 0.6 meter per second per degree Celsius. Actually, 0.6 is constant. Okay, so take note of these two equations. Okay, let's try. Let's try to solve problem. What is the speed of sound in Metro Manila, for example, if its temperature is 30 degrees Celsius? So, speed of sound, the equation of speed of sound is V is equal to 331 meter per second plus 0.6 meter per second times the temperature niya over degree Celsius. Actually, itong degree Celsius nito, dapat nandito yan siya, pero gibaba lang ni ma'am para madali tayong makakancel. Actually, pag ganyan yan siya, degree, tapos dito ang degree Celsius class. Pero gibaba ni ma'am para makancel natin sa degree Celsius ng temperature, para makancel yan siya easily. But still, we did not change the equation. The same lang din ang equation. Okay, so ang gawin natin, yung temperature na 30 degrees Celsius, ilalagay natin dito sa letter T. So this is now the solution. So V is equal to 30 meter per second. Substitute the value of T or temperature. So you write here 30 degrees Celsius. So ang gagawin mo is, can you get your calculator now? 30 times 0.6 plus 331. What's the answer? 30 times 0.6. The answer is 18 meter per second. Cancel this degree Celsius and degree Celsius. So what is left now is meter per second. So when we multiply 30 times 0.6, what's the answer? 18. 18. Oh. So kaning answer sa 30 times 0.6, i-plus natin sa 331. What's the answer? 331 plus 18. So meter per second. This is the speed of sound when the temperature is 30 degrees Celsius. So the unit is meter per second, and that is the unit of velocity. The speed of sound is 349 meter per second. Let us gawin natin ito. The temperature of Davao City is, sabihin natin, 35 degrees Celsius. What do you think is the velocity or the speed of sound? Can you compute? So 35 times 0.6, what's the answer? 21 plus 331? Very good. So therefore, if the temperature is increased from 30 to 35, what happened to the speed of sound? Na-increase ba yun? Yes. So yan ang sinasabi that the temperature really affects the speed of sound. So the greater the temperature, the greater the speed of sound. So temperature really matters or affects the speed of sound. So you know now how to compute the speed of sound using temperature? Very good. Okay, next. Ngayon, given na ang speed of sound, let's solve for the temperature of the medium or air. What is the temperature of an air if the speed of sound is 346 meter per second? So what is the given? So given ang speed of sound which is 346 meter per second. So compute for the temperature. So we all know that the equation for the temperature is V is equal to 331 meter per second divided by 0.6. So substitute the value of velocity, the value of speed of sound, 346 meter per second minus 331 meter per second over 0.6 meter per second per degree Celsius. So ang gawin natin ngayon is 346 minus 331 divide by 0.6. What's the answer? Pareho ba tayo ng answer? 25. So bakit naging degree Celsius na lang ito? Okay, ganito. Meter per second minus meter per second, the answer is meter per second gihapon class. Cancel meter per second sa numerator and then cancel meter per second sa denominator. So what is left now is degree Celsius. So that's the unit of temperature. The answer is 25 degrees Celsius. What are the properties of sound? So there are only two. We will discuss only two properties of sound. We have reflection of sound and refraction of sound. Let's see the difference between the two. So when we say reflection of sound, this is turning back of sound wave as it hits a barrier. Yung pagbalik ng example, mag-sing ka. And then, pag maabot yan siya sa mga walls, lalo na solid, it will bounce back, turn back. That is what we call as reflection. So when you sing, for example, in a bathroom, and we all know that bathroom has a hard walls and close lang ang iyahang dimension. So it forms a echoes. Actually, echoes are example of reflection. So pag marami na masyadong echo, this is called as reverberation. So echo is an example of reflection of sound. So pag makarinig tayo, for example, ng mga echo, this is an example of a reflection. Meaning, nag-bounce back, nagbalik. Kung mag-shout to, for example, sa middle of the, hill. Example, mga mountain or sabihin natin doon sa kagubatan. What happened is, the sound will hit the mga bundok, trees. Usually sa mga bundok yan siya kay solid. So mag-bounce back mo nang mapansin natin merong parang nag-ulit ng sinasabi mo, echo. So echo is an example of a reflection. Pag marami ng echo, ang tawag doon is reverberation. Okay, so echo is an example of reflected sound. So reverberation is multiple reflection or echoes. Second property is refraction. What is refraction? Is another property of sound described as the bending of sound. Ang sound kasi pag mag-travel from one medium to another, like for example, from air to water, ang mangyari is mag-bend, mag-change ang iyahang travel. Mag-bend ang sound. So for example nito, ang first na medium dito sa lower, warmer. And then sa taas na air niyan is cooler, for example. So what happened is, mag-pass dito, pagdating doon sa cooler, mag-bend, mag-change. Change ang iyahang speed of sound. That is what we call as refraction. Pag-change sa speed of sound. Same thing dito. Nag-start siya sa warmer to colder. So, nag-bend ang iyahang sound. Instead na mag-travel siya in a straight like that, nag-bend siya. Bending. Kani, dapat ba dire-diretso lang ang iyahang sound pero nag-bend siya down. Okay? Nakuha? The bending of sound is what we call as refraction. So, ito din ang dahilan bakit nagkakaroon ng concert during nighttime sa open field because of refraction.